Hey everybody, so we're talking about finding the volume of a solid generated by revolving around the y-axis, this following region. So it's y equals e to the negative x squared, which is this graph here. And then we want to bound it by the y-axis, okay? And then from x equals 0, so that would be this, okay? From x equals 0 to the positive x coordinate here. Positive x coordinate. Positive x coordinate of the point of inflection. So that would be here. All right. Right there. So we're basically looking at this region right there. All right. And then we're rotating it around the y-axis. So it's going to kind of rotate around this direction here. So this is going to rotate out to here and back. So we know that a volume of rotation is pi from A to B, and it's the sort of the bigger function squared minus the smaller function squared. Okay, again, these are squared because it's pi r squared. This is going to give us the slices of radii. All right, and so let's go ahead and do that. Now, to find the point of inflection, remember what we want to do is take the second derivative, set it equal to 0, and solve. All right, so you can take a look at that. Just one thing you might notice, I factored out the e to the negative x squared in this step. I just used a regular normal derivative, then I used the product rule, okay? Then I factored out the e to the negative x squared here, and I got this. Now, this function here is never 0, so it's a no solution. So you set this one equal to 0, solve, and it turns out you get the square root of a half, okay? And it's a plus or minus, but I'm going to use the positive version of it because it says it's the positive x coordinate. Then to figure out the y coordinate, I went ahead and I plugged it back in. So you plug a root of 1/2 into here, and it turns out you get e to the negative root of a half squared, so negative a half. So there's my y coordinate there, okay? Now that y coordinate is going to be my lower bound, and my upper bound is going to be the top of this graph here, which happens to occur at y equals 1. And you know that when we do a solid of revolution around the y-axis, we do a dy. My upper and lower bounds are y coordinates, my lowest y coordinate, my highest. And my functions need to be in terms of y as well. So I'm going to take my function, y equals e to the negative x squared, and put it in terms of y. And when I first saw that, I said, oh man, this is going to be tricky. So when I went ahead and I plugged it in here, and then I forgot, oh wait, it's squared. And so this root and that square actually cancel each other. So that's pretty spectacular. This 0 goes away. By the way, this 0 is the lower function, which happens to be this one right here, x equals 0. And then the upper function is x equals the root of negative ln y, okay? Now, so that is where those two things, this guy and that guy, come from. Okay, so now the idea is I square this square root, it goes away. The integral of a negative ln y is just 1 over y. Okay, and I moved my negative out. That negative got pulled out to there. And then I evaluate this at 1 and this here. So here's my final result, a negative pi, and I'm going to evaluate it at e to the negative 1/2. And I'm going to evaluate it at 1 as well. So this is actually just 1 over 1 right there. And the e to the negative 1/2 is here. All right. So there it is. There's our solid, our volume, the solid of revolution.